Welcome back. Today we're looking at another tool in my father's vintage tool collection here. This particular one is a lamp slash voltage tester, model number LT130, and it's from Etcon. This is a pretty old unit. I did look these up online. They are actually still making these, believe it or not. A little different looking. They still have the same plastic boxy kind of look to it, but the decal is a different color. I'm not sure where you can pick these up anymore, but alas, the website does still exist. I will put a link in the description below to where I found the information on this. Unfortunately, they gave you some insight as to what this thing does, but it didn't really give you a manual or anything to download, which is kind of a bummer because I don't have the information on this, but I do know what it does. Just recently, Father's Day passed and my dad was over here and I showed him some of the tools I was cleaning up and contacts I've done on stuff, and cleaned the contacts up, got the things working again, and I pulled this out and I said, "Hey Dad, what's this do?" And he explained it to me, and I watched a video on some newer ones that Milwaukee makes that is actually really cool, but I'll get to that in a minute. So what does this do? Well, as you can guess, it tests voltage. That's the easy part. It goes in obviously AC volts, 5, 12, 24, 48, 120, 208 to 240 on one light, 277 and 440 to 600. Now, those of you who are familiar with residential electricity will recognize the 120 number right away, and you will also recognize the 240 number right away because that's a common number. 277, a lot of commercial buildings use 277 volts for the actual fluorescent lights in the building, and 440 to 600, that's more, I'll call it industrial stuff. You don't really work with that a lot, but some of these devices, do use higher voltage, especially when it comes to fluorescent lights and whatnot. Anyway, the lower voltages are simply just that. Now I can tell from looking at the front of this, these are actually neon indicator lights, where these seem like they're more LEDs. There's an LED indicator here, there's a little tone, a push button. On the bottom we can see here there are two, looks like banana jacks. At the very top there's this little probe, which ends up being an actual antenna. You get the idea. I'm not going to pull the whole thing out. It's quite long, 5 feet, 6 foot, something like that. And then you have a slot over here for a probe to go into. And we'll get into all that in just a moment here. This comes with maybe a cigarette burn, or who knows what this went up against. This was used in an industrial application. My dad never smoked. He wasn't a smoker, so I'm not sure how this got on here. I used to be a smoker, so I identify that as being a cigarette burn. It may not be, but it adds to the character. Back, just plain, couple screws. Open up the cover here, and we'll see. There's actually a neat thing. There's 3 9-volt battery connectors. See if I can show you those real quick. They were really clean. There was a little bit of corrosion on these terminals here along the outside. I just used a scratch brush and just cleaned that right off. You can see inside is a handwritten date, 3/15/89, I'm going to say. So yeah, I was born in 81. This is from 89, so it's almost as old as I am, which is kind of cool. I like vintage stuff. It's neat. So we can see right here, there's one of these for voltage, and then the other ones here say lamp. They are hooked up, it looks like in series, so you're doubling the current capability. I have to double check that because it looks like the 2 reds are connected and the 2 blacks are connected, and usually when they're doubled up like that, that's a parallel connection, I'm sorry, and you're getting double the current. If you hook them up in series, you get double the voltage. So just taking 2 9 volts like this, you connect positive negative just like that, and when you connect the 2 terminals here, you're actually getting 18 volts instead of 9. So that's the series connection. Parallels, when you put them side by side like this, positive to positive, negative to negative. Connect these terminals to each other, you connect those to each other, you get double the current, still 9 volt. Anyway, we're going to take a poke see inside this here. I cheated a little bit, I cleaned the contacts and plugged it in, and of course it works, which is always a bonus. But I want to see how it works. I'm kind of curious. Now, do I put the batteries in it and show you guys how it works first? Do we open it up? Well, Dave Jones says don't turn it on, take it apart, and a lot of the people I watch that watch him say the same thing. So yeah, let's go ahead and take it apart. I'll spare you the boredom of taking the 4 screws out. All right, 4 screws later, and we should be able to open this up. And what do we got in here? All right, well, that was right. We do have the 4 neon tubes, which makes sense at the higher voltages. And then for the lower voltages, we do have your typical LED arrangement here. Now, I kind of cut ahead here and told you this is a voltage tester and it's a lamp tester, and showed you the basics of it and said let's open it up, but I didn't really explain what this thing does, and I think I should pause for a second. This is used to test, we'll call them high voltage fixtures, your fluorescent bulbs, your sodium lamps, there's stuff like that where you can't, you just hook them to a regular fixture to turn them on to test them. You need a special fixture. Fluorescent's the first thing that comes to mind. Even these neon tubes, you need a striking voltage. So you usually they're hooked up with some way of doing that. Little quickie, Nixie sticks. They're all obviously neon tubes, and there's circuitry involved in making them strike and light. But we can test these with this tester, and that's the important part. And why does it have an antenna? Well, maybe you're trying to test lights that are installed. So you would use this antenna, and again, like I said, it's quite long. And you would hold this thing in your hand and point it up in the ceiling, like in an office setting, and point it to the tube, and like a fluorescent light tube, and then push this test button, and it sends electricity, voltage, current, and sends electricity up through this antenna, and it actually causes the material within the fixture to glow, and that glowing shows you that lamp is good. So that's all this does, is it tests the lamp and it tests the voltage. You need the little jacks down here for the voltage part, obviously, and then you'll hold your lamp up to this. Now, this being an older device, it doesn't have any cautionary stuff on it to tell you don't touch this thing. I mean, you would think not to touch it. I'm sure the manual has it plastered all over, but there's no little like lightning bolt symbol with the customary little triangle around it anywhere saying warning, don't touch it, right? You don't see any yellow caution. This is very like, where are you going to pick up and push the button and the little light lights up? You don't think anything of it. But if you touch this, you get quite a wallop. I haven't tested it out myself because I'm just too afraid, honestly. It's really, I'll show you, if you touch this to a grounded plane, it's like a mini arc. It's almost like, when you take a 9-volt battery and touch it against something, you get that little spark. Yeah, but this thing's like it's not a long spark, but it's something where you're like, holy, when you look at it, you're like, holy crap, that thing's pretty dangerous. And going back to the videos I've seen of the newer ones, they have the same telescoping idea, but on top there's a little trough, I'll call it. So when you actually take the fluorescent light and push it up to it, it's not just a little contact, it's the actual big thick bar, like a rounded out bar almost. And they actually test the ballasts too, where when the light's off, you push the button, it lights the light. But when the light's on, this thing will beep to let you know that the ballast is still good. This doesn't do that. So having the newer meter is definitely a better thing, but for what it is, it's still pretty cool. But going back to the whole thing on the inside here, like I mentioned in other videos, I'm not an electronics engineer, so a lot of the stuff doesn't make much sense to me. I mean, I don't really see anything spectacularly large in here. I mean, there's, your standard, through-hole components. There's some diodes here, a couple of resistors, very large resistor up here. Sorry, off camera. Yeah, your diodes, your resistors, some more resistors, obviously, LEDs, and, your typical surface stuff, all single mount boards. Boards are a little crusty. They could use a nice cleaning. But yeah, look at the old traces in this thing, huh? Pretty neat. And yeah, there's some trannies in here, some transistors. Then you got your little beeper mic, your little piezo buzzer up here, which just has a hole in the front cover. Not sure how well they line up, really. What's this guy right over here? It's an 8093 little guy right here. We have a capacitor, big capacitor in here, and then this guy. And it makes me wonder, is that a transformer? I really can't see in there very well. There's something underneath it. I should take this apart a little bit further. It looks like it comes apart pretty easily. Let's see if we can figure out what that device is there. I'm thinking it's a transformer. But like I said, I really can't tell. It's an inductor, or yeah, I'm not really sure. I couldn't find any data on this, any kind of schematic or anything. So if you have any insight into how these things work, I'd really appreciate it. There is a little potentiometer down here. I'm assuming that's for trimming out, you know, getting the actual test voltage. It's a pretty neat way this LED's hooked in up here. It's got like crimps on it. It's just sitting up in the air. And these are the old style LEDs. Look, they actually have like a rounded out little pattern on there, like a little radiating pattern to spread the light out a little bit. Yeah, I mean, nothing too exciting. You know, I was expecting this to work similarly to how the ionization devices work, with the voltage divider or a voltage network of some sort, where it's not the voltage divider, it's more like a voltage multiplier, where it would, you know, boost up the signal of the 9-volt batteries. But I don't really know. Like I said, I'm not an expert in this stuff. I can take it apart and show you guys the inside though, if you want to see that. So let me go ahead and button this back up. We'll install some batteries in it. I just happen to have 3 sitting over to the side here, and we can see if we can get this thing to work. You know, as I'm sitting here screwing these screws back in, I'm looking at this date 3/15/89. It makes me think, was that date written in here when they built the unit? Or was that date written in there when they issued this unit to, I'm guessing, my dad when he worked for the plant? Or whoever they gave it to. So it's kind of hard, because if it was given to him in '89, or again, maybe that was a replacement date, you know, because some of these tools that he gave me, I noticed, had dates like that scribed on them or written in them someplace. And I think that was more of like an indication as to what you should do with this device. Like, maybe every year they had to get a new one for reliability purposes. Or instead of recalibrating their multimeters, they just went ahead and just bought new ones. Or, you know, it could have been worked out in the budget automatically. Or, you know, maybe they leased them or something like that. I don't think they leased them, because he ended up keeping a lot of these things. It was kind of one of those, we're just going to get rid of them anyway thing, I think. Not sure, but you can see those triple 9-volt batteries fit in there pretty snugly. And this back just snaps right on. Push the button and you get a little light up, and you can see the LEDs kind of flash for a second. Now what does this do? Well, like I said, it tests fluorescent lights. Here's your standard, now kind of ubiquitous screw type Edison ended compact fluorescent bulb. This particular one here is, if I can find it on here, 13 watt. Okay. I'm just going to sit this over here. It's just a pillbox. It doesn't have to be grounded. It's just for display purposes. Here's that little antenna. I push the button. You see it light right up. Pretty cool. Let me kill some studio lights here for a second. You can see that a little bit better. And it depends on where you put it, where you can get it to light up. And all you're doing, like I said, is you're exciting the actual material in here. And maybe you could pick it up, but you can kind of see right where that antenna touches. It's the most intense. Camera's not really picking it up, but it almost has like a plasma ball effect. We're right underneath that actual probe. It's the brightest, like a red spot on the other side of the glass. And if you're curious, you can flip this over and you can actually hit the metal contact here and make it light right in your hand, which is kind of cool. Now the cool part about that is there's a power supply in here. If you've ever cut one of these open, it's not just positive or negative or hot and, you know, hot and neutral, I should say, in an AC situation, going directly to the terminals. There's a ballast in here. There has to be, because the voltage it takes to light these. So this is putting out a high enough of a voltage where it can light it, but yet it's still a low enough of a voltage where you're not blowing out the internal supply here. I do need to turn off the light on my camera. That's the one I have to kind of go in here manually to do, so bear with me. All right. If I could pick up this arcing on here, I mean, it's not like major, but it's enough. You can see that. That's got to give you a pretty good wallop. I mean, you can even put it on the collar here. Yeah, you can see it. Look at that blue spark, just sparking right away there. I have no idea. I mean, I can hook this to my multimeter and tell you. I mean, I had the button pushed off. There's no capacitance here, so nothing. I'm sorry, guys. I'm not going to push this and hit that. That's just not going to happen in this video. I'm not that daring. But I will show. I have some of those neon tubes over here. Shut some more lights off. This is my Nixie stick. And if I go ahead and put this on here, you can see I can excite the actual neon lights. Just like that, which is really cool. And if I touch this to the base, sorry, my freaking camera light here is on auto. There we go. Alright, if I push it right here to the base, I can get the wall to light up at once, which is kind of really cool. And that actually, that's a good way to show you. If I put it over on the hot, they all light. If I put it over on the neutral, only half light. And that's a good way to show the circuitry involved in this. I can actually hold this in my hand. I'm not grounded out against anything. See? Oh, how pretty. It's like a Christmas tree. Yeah. Here's another one. This is just the long stick version as seen in my original videos and the one that Big Clive originally put it up. Yeah, you can see. Go ahead, put it on one side, you only get the top one to light. Put it on the other side, you get every other one to light. And if you pass it along, you can check these. Oop. And yeah, on the other side of the circuitry, if I just put it in the middle here, I can make any light, you know, right up the line here. Obviously, for these smaller bulbs, it's probably not as practical as a tool, but lighting fluorescent bulbs definitely is. I don't have any long fluorescent bulbs here in front of me, so I can't just demonstrate that effect on the bigger bulbs. Nor do I have any sodium lamps or anything like that lying around. It's just not something I work with every day, so I don't have that here with me. I do use them at the place I work for, and maybe we have a spare bulb they'll let me borrow. So if I want to do a follow-up video one day on this thing, you know, we could always try that if you guys are interested in seeing that. But I mean, you get the gist of it. I'm sure you could probably pass this right down the middle and get a lot of it to light. I mean, I thought it was kind of cool. It was kind of one of those, you know, people probably use these things every day, and it's probably just used and put in their pocket and not really thought about afterwards. But I picked it up, and I was like a little kid in a candy store. I was going, oh boy, that's kind of cool. Look, I can make things light up. Oh, cool. Look at, you know. And yeah, it was good fun for a little while. You know, here's another Nixie stick if we want to make that one light up. This one is just on a circuit board design, but yeah, you get the idea. Now, what about the voltage side? Well, there's a little bit of this I didn't mention. This actually came with a tool pouch. You can see it's old, you know, old leather worn tool pouch. You know, it's indestructible though. Look at the belt clip on it. They still use this design nowadays. I have a knife, a big camping knife that's got that same kind of thing in the holster. And let me tell you, that's very hard to get off the belt. So that's definitely a very good holster. But inside here, there's a couple probes. There's actually 3 probes. I may have mentioned in the video I did a while back now about kind of the introductory to all these different things. Like here's a collection of my dad's old meters. And I mentioned I had this one lead. I had no idea what it belonged to. Well, I found out through an eBay ad, believe it or not, eBay auction for this. This is a clamp, see, and the other end of it is a shielded ground cable, I guess you'll call it, negative. It's kind of hard to get in here. It does go in though. Oh, that's right, you have to push the button. Oh, wait, this going in. There it goes. And then you could use this as a grounding point, and this is your positive point, I'm assuming. Again, I don't have a manual for this. I gotta find one. That'd be really helpful. The voltage side's easy. I know how that one works. The little grounding cable has something to do with the lamp tester, but just plug that guy in here. Just plug this guy in here, and then you can, you know, one-hand it, just like regular multimeters has. You can just stick that in like that. Get your other probe in your other hand. We're gonna go up here to the outlet I have in my lamp. And if I remember correctly, this thing beeps. Yeah. So sticking this in here immediately makes the 5-volt light up. And then when I kick this in over here, you get a quite annoying buzzing sound. It almost sounds like the electricity itself. And the 120 light will actually light up. See if I can get you a little bit of a closer shot without, you know, one-man camera team over here, just myself. So sometimes, all right. Hey, there you go. I don't have 240 or anything higher than that to test. Although I will say, playing around with this lamp tester made the 600 light up. So I don't want to sound naive, but does that mean it's pumping 600 volts out of this little end over here to make this fluorescent stuff light up? I don't know. I'd love to do more research on this thing and find out for you guys, because it's kind of got me baffled. Like I said, I would hook it to my regular meter, but I'm just too darn afraid to just have this button be pushed and have my nice fluke there blow up on me. I mean, I suppose it would handle it even if it's 600 volts. Should we do it? I think I'm going to do it. Let me set up everything. We'll be right there. Ooh, this is a bit dubious. Okay, I got the ground cable hooked up to the bottom of the device here. Should put this into continuity real quick. Alright, well, it's in continuity diode mode, so I'm getting read back on there. Let's put it back to volts AC. 0 volts AC. Positive hooked up to the top here. Negative hooked up to the ground clamp. Let's do it. Oh, it's not coming up with anything on volts AC. What about DC? Nothing. That's a bit weird. If I take that off. I don't know. Can't be only 1.2 volts, 1.3 volts, can it? Is that possible? Nothing on DC. This is an auto ranging meter, so one would think it would automatically range to the right range, right? I'm not sure, people. What if I put the lamp on top here? Oh, that's curious now. Alright, I'm baffled. I admit, I'm baffled. It seems if you have the ground cable on and you test it, the light doesn't light and you get nothing on the meter when the lamp's on there. When the lamp's not on there, you still don't really get much of anything, but when I take the ground off, we push it on here, we get 1.2 volts AC. And the light does light. Weird. Could it really be that low of a voltage? Low voltage, high current? That's why we're getting sparks? I really don't know, honestly. That really didn't prove anything for me, but it was kind of a fun experiment anyway. Well, anyway, I don't really have much more to add to this video. I just wanted to go over this thing and kind of introduce it and show that, you know, even though it's sitting on the shelf for years, it still works the way it's supposed to, which is great. No battery corrosion issues on this one, unlike the other ones I've done in the past, which is also great. If you do use the nice little pouch, it sits in here relatively nicely. I'm not sure what this little loop over here is for, maybe for hanging the leads off of when they're not stuffed in the pouch in the side. Yeah, it's a nice little thing to have added to my collection. I'm not sure how often I will use it. It's not something I know I'm not going to use every day. I don't do, you know, commercial or industrial electric work per se. I mean, I do things in a jiffy, but that's not my main forte, obviously. But again, tools are like anything, you know. If you have the right tool and you have the knowledge on how to use it, you can pretty much do anything. You know, that's definitely something that rings true. So having it in my arsenal is definitely not a bad thing. And I welcome it to my collection. So with that, guys, I want to thank you for watching. As always, I should have another video coming up this Thursday, obviously, as always. I got that phonograph that's been kind of sitting in my room here for the last few weeks that I got to get to. I haven't heard anything from the owner of it yet, so they're being patient with me, luckily. But it's something that I do have to attend to, because after all, I don't like leaving projects unattended for long periods of time. Only reason why I haven't gotten into it yet is because it's mechanical. And while I am a jack of all trades, a master of none, some areas of expertise are not my expertise. And mechanics, you know, I've worked on cars, I've done different things over the years in certain capacities, but clock springs and stuff like that, you know, a phonograph is a very large winding kind of device, and you know, it's 103 years old. I don't really want to mess it up worse than it already is, but it's already not working and hasn't for the last 10 years. So that being said, I'm sure it's not such a big deal, but you know, I want to kind of do my proper due diligence on the thing and make sure I have the researched and the information looked up on how the thing works and all that fun jazz before I actually go willy-nilly into the thing with a screwdriver and a wrench and all that to try to take her apart. But alas, I'm pretty close to the stage where I should be doing that, and I want to say, you know, in the next night or two I should be able to dig that thing out and start working on it. So expect a video on that coming up soon. As far as the meters go, this is going to be an upcoming thing. We've obviously looked at this one. We've already looked at the Fluke before. We've already looked at these guys before, you know. So I'm getting through the pile, but alas, there are quite a bit more. Some big boys up here, some Simpson meters, some things like that. So we'll get all to that in the very near future. But as always, if you're not a subscriber, please subscribe. That's how you'll get notifications on videos like this. You'll also get notifications when I do special things like giveaways and things like that, which I'm currently doing. I promised I wouldn't mention it, but I am. You can go down to my Facebook page, the Pileggi Technical Services Facebook page, and you can get information on that there. There's also video floating around on my channel someplace here if the competition's still in effect. You can find that video and enter if you'd like. And thanks for watching. See you next video.